Cool. All right. Hello, everyone. Welcome to Serverless MN. I'm AJ Steivenberg. I'm your host this evening. Bryson Tyrrell will be presenting. I want to just welcome everybody. If this is your first time, if this is your 100th time, thank you for joining us here at Serverless Minnesota. We are the group talking about serverless technologies of all kinds. We just love not managing infrastructure. So the whole point of this meetup is to talk about how we're embracing serverless in our day-to-day or in the side jobs, side hustles, or if you're trying to learn, what you can do to help embrace serverless technology at your job. This is a place for that. We've had a number of speakers from all over. COVID has been a blessing and a curse. We had to give up our space at MentorMate. However, we were able to have a bunch of folks kind of from all over that we never maybe would have gotten to come in person, were able to come and speak. So that's been cool too. As part of that, we're looking for other speakers. So if you have a topic you'd like to talk about that's even tangentially related to serverless software or serverless technology, love to hear it, love to have you. So you can send us an email, hello@serverless.mn, or you can reach out via the serverless Slack group, where I'll post a link for that in chat. Otherwise, other announcements. So we do every meeting, both in person and virtual, is governed by a code of conduct. I sent a link to that here in chat, and I just want to, if anyone does need to make a code of conduct report, you can do that by emailing hello@serverless.mn. Otherwise, you can keep up with us and all of our latest events and things that are happening and goings on at our meetup page or at serverless.mn. Otherwise, the sponsor for this evening is Serverless Inc., a company I work for, sponsoring the Zoom call, which is why we're able to get any number of folks and also record the call. So if you're looking to try out serverless for the first time, the serverless framework is a great choice. I recommend it. Bryson's going to talk about SAM tonight. SAM's also great, so feel free, please. There's no wrong way to do serverless. So I just want people to be able to use the technology and build serverless software. So with that, I'd love to introduce Bryson. He's a staff systems development engineer here at JAMF Audio right here in Minneapolis, Minnesota. He focuses on serverless development, and tonight he's going to talk about CI/CD with SAM. Bryson, take it away.
Hey everyone. AJ was asking about my background earlier because I have this great backdrop of where I sit in the office at JAMF, and I told him I had a small joke about that, and the joke is I'm actually at my desk right now. That picture was framed nearly perfectly.
That's a good joke.
It's a really good one. So I'm also just sort of marveling at, what was that?
Is everybody back? Is it just you?
No. It's a case-by-case basis if you need to use the space. Right now, we're not fully opened up. I'm also kind of marveling at the amount of stuff I left here. Like, I have a lot of swag, including this right here, which is the greatest AWS swag sticker of all time. It's so great, I can't ever actually bring myself to use it. It just sits here in my desk. I'm going to put it back in there now for safekeeping. All right. So we're going to reserve Q&A to the end, just because this presentation kind of came together really quickly. I had a lot of life stuff get in the way of actually working on it. So I'm mostly prepared. If you saw me on broadcasting on Twitter, like you're gonna watch me wing some of this really hard. We'll see how far I get. All right, AJ, give me a thumbs up on the screen share.
Yeah, the stream looks good. Audio sounds great. Take it away.
Yeah, Keynote's new play slideshow and window feature is awesome if you haven't used it yet. So I'm not actually full screening Keynote right now. It's just in a window. It looks great. All right, so CI and CD for SAM. If you want to reach out to me outside of this, that's my Twitter handle there at the bottom. So to preface this is a little bit of an opinionated presentation, because my group here at JAMF, and also we've influenced other teams at JAMF, we're kind of standardized on SAM for our serverless applications. And a lot of what we do is around that. And really, my team is a Python shop. It's effectively YAML. Like, you're all using YAML. It's close enough to Python that you're halfway to being Python developers. Come along for the ride. Again, we're using the serverless application model. as AJ mentioned, like you've got serverless itself with the confusing name. You also have Terraform for some of your serverless apps. We have the CDK out there now from AWS. There's lots of really great options for serverless AWS development, and really, pick the one that fits with your group and what you're doing best. In our case, we started with SAM, and we've been doubling down on SAM ever since. Our code repos, though, are over in GitHub. So kind of what I'm doing here is I'm walking through what our stack is, because the stack that we have is kind of what has determined what our flow is and how we actually do this. So this gets back to the opinionated presentation portion of all this. Like I'm telling you how we do it based upon how we what tech we have and what services we have, and kind of what we decided on. Like some of the things I talk about aren't going to fit for everyone, but that's okay. One of the great things about these meetups and these presentations is that you get exposure to different ideas, and you apply the ideas that you think are good, and you can ignore all the ideas that you think are completely trash, which, half my presentation might be that. Let's find out. We use code pipeline. It's not that bad. There was an asterisk on this before, but I got rid of that. It's really not that bad, and I'm going to walk through why we like code pipeline. We use code build, and I do mean it. Code build is kind of how we all wish Fargate really operated, but it is what it is. And then I'm going to talk about some future stuffs at the very end. And this is where I ran out of time, so I don't really have a lot to show you, but I will, discuss through some of the things that I've been thinking about based upon where we are today and where I actually want us to be. So my team's workflow is actually really similar to GitHub flow, right? All of our development for all of our services are short-lived branches for features or changes, and then they get merged back into the main branch. We use GitHub branch rules to enforce pull requests for that integration branch, which also happens to represent our environment that we deploy to. So, you have to pass all the marks in order to actually have your pull request even be mergeable, which ties in a lot to some of the things we're going to be talking about. We treat pull requests as the integration point. Like your code should not hit the integration branch if it's going to actually bomb things out. And if it's not going to bomb things out, then it should be allowed to just proceed on through. And sort of like how GitHub Flow talks about it, you have a short-lived branch, you do your commits, you open up your pull request, you have your conversation, changes where needed, and then you merge it back in, and then it should deploy off. That is what we do. My team builds a lot of small services that make up a much larger service, and then also some sidecar services around here at JAMF that are just their own little application. One repo per application. There might be a whole bunch of Lambda functions and other pieces of infrastructure that make it up, but it's one app per repo. It has its own pipeline, and it deploys independently. That's how we do things here. Then the last piece is that upon deployment, that's also where we actually do system testing. And I'm going to touch on this a little bit. Some of the things that we do, some of the things and ways we do system tests are interesting for the kind of thing that we've built. And I'm actually going to say it doesn't apply to most use cases, but I'm going to talk about the trigger, about how we trigger off of that and the points at which we trigger off of that, and some of the things in SAM you might want to take advantage of in order to actually leverage, running end-to-end testing as a part of your deployment pipeline. So we are here right now. We're going to talk about the developer experience. Like everything starts with the developer branching off and getting started on a feature or a bug or whatever. So we're going to talk a little bit about Pythonic SAM. So for those of you who are not familiar, I went out and I went to the website and I copied AWS's marketing speak, and then I just threw it on the page right here. SAM is an open source framework for building serverless applications. And in my opinion, it really just exposes the elements of a serverless app in the way that CloudFormation should have done it in the first place. The really great thing about SAM is, even though it's categorized as a transform, it's actually more of an extension, and it's a first-party extension, which means that even though you're using a CLI tool to do some of this stuff, it actually is fully integrated into the entire AWS ecosystem, and you don't have to do any special steps when it comes to actually deploying the thing in CloudFormation. That's cool, and that itself has a whole lot of value. Now, I'm going to throw him under the bus right now. Eric here is the reason I'm here right now. He is the man. If you want to know more about Sam, he's the man with the plan. Go at him. You can add him right there. And I strongly encourage you to go check out Sessions with Sam. If you want to get started with this stuff, like I'm not going to be covering any basics here, but if you want to get started with this stuff, go to serverlessland.com and look for the Sessions with Sam videos. And quite frankly, like there's a whole bunch of amazing content on serverlessland.com anyway, blogs, videos, whatnot, examples. And yeah, you'll be able to find something for everything. And it's a really great resource. I encourage you to go. All right. So before I actually get talking to anything else, I want to actually walk through our repo structure because, again, there's a whole bunch of things about how we actually build our serverless apps that dictate the way that we've actually set all this up. So I want to walk through like what our repos look like. And like I mentioned before, one app per repo. And with very few exceptions, we try to keep it one app per repo so that there's really one template, and that template lives at the root of it. And this is the SAM/CloudFormation template. This defines the application. Now, Python, not even just Python, but just Lambda functions in general get interesting with SAM because you do have to define the packages that make up that Lambda function on a per function basis. I'm pretty sure this is the same with Node when you're defining the modules that it's going to require. The way that we do it is that for the developer environment, so when you're building these things locally, you don't want to actually have a whole bunch of, and this is where people might disagree with me, but you don't really want to have a whole bunch of independent Python environments for every single Lambda function that you're doing, especially because ideally within your serverless application, if you have a shared package, all your functions should be using the same version of that package. So the way that we approach this for our repos is that we're using pipenv for managing our development environment. And really when we're working on the serverless app, the IDE that we're using, which we standardize on either PyCharm or Visual Studio Code, you have that one Python environment so that the linters and the auto completion features and all that other stuff are all going against that environment when you're in the different separate files for each Lambda function and you're working on them. And then, of course, the Lambda function itself has its own requirements file. What I don't touch on in here is that we also have some other tooling that allows us to sync our requirements files across all those functions back to what's in the lock file for pipenv. So that's kind of how we approach this. All right. Another thing that you'll find in every single one of our apps is the build spec file and the pipeline file. So the pipeline, like I said before, we use code pipeline. We define that in code as well. So our pipelines are defined as our infrastructure as code, just like our applications are infrastructure as code, effectively. Those are all maintained in the same repo. And then the build spec file for doing that is in the repo with that. So that way, when it goes through, code build can pick up on that build spec and then go do its job. And we'll talk about that a little bit later. Tests. Always test. Annie taught me that lesson. Always test. We'll talk more about tests later. Now, this is definitely somewhere where I diverge from some members of the community. I like my Lambda functions like I like my Python code. It should do one thing and it should do that thing well. I don't prescribe to the idea of the monolithic Lambda where it's one big function with a bunch of independent handlers. What my team has done actually is we approach it one of two ways. One of our engineers, Anju, she came up with a really great solution where taking advantage of the way that Python's setup system works, like the pip install system, we can either have shared code that's internal just to this application, can actually be a directory in here, and then it's pip installable across all those functions. Or what we actually do with code that gets shared across numerous stacks, we're using Lambda layers. So shared code is disseminated one of those two ways. Usually it's in Lambda layers, but one of those two ways. And then like for an API, each endpoint on that API is its own Lambda function. That's how we approach it. There are other approaches to that. The monolithic Lambda, where it's not really a monolith, but the idea that all that shared code is going to be in that one file, and then you have different handlers for the different API endpoints you might be doing or the different actions off of events. That is another way of doing it. That's just not what we do. So you'll find that in our repos, our code is structured like this, where you have the source directory, the event source, and then the individual functions under that. Oh, there we go. And then lastly, and this is where we're going to do a lot of talking on, GitHub Actions. I'm not even going to elaborate on that. We're going to be talking about this a lot in a little bit here, but GitHub Actions defined inside the repository for the application. Very important. So there are some other things that we've done to make our lives easier, and one of those is automatic code formatting. And this is a rule. And we have decided as a group that we can have it in any color we want as long as it's black. And black is a Python, it's not simply a linter, it is a Python code formatter. It will rewrite your file to what it decides is best. So this is also something that we know how to integrate into our IDEs. So like every time I'm working on a file in PyCharm and I hit save or I click away from the file, black auto runs against that file and reformats it for me. The benefit of this is that no matter who wrote the code, it all looks the same, which is important for readability. It doesn't mean that we all wrote the code in the same way. Like some of us are much more functional versus some of us are a lot more object oriented. We're going to get differences like that. And that's where the review is actually more beneficial in saying like, do we want to write it this way? But there are no nitpicks about formatting. And, you know, we willingly surrendered our free will. And it's not always a bad thing to do that. Like we decided that this piece of code will dictate our life. And that's fine. And it's actually worked out pretty well so far. All right. Next up is the testing portion of it. And this actually starts getting into a bit of what our CI/CD flow looks like. And you're going to start piecing things together. We standardized on PyTest. So across all of our projects, all of our Python serverless apps, we're leveraging PyTest for this. One thing that you won't find, though, is Modo. Early on, we had some projects that used Modo, and then Modo has since been abandoned in favor of actually using Modo 3's built-in stubber. So the beautiful thing about the stubber is when you are doing an API call to AWS using the Python SDK, Modo 3, it's going to validate your input. So if you actually write a bad Modo 3 call, it's going to call you out for it, and it's going to say this is wrong. It's not going to do things like validate the service name that you're trying to connect to, or not the service name, but the resource name that you're trying to connect to, like, hey, this table name's wrong, or any of that stuff. But when you're actually like stubbing out API calls inside PyTest itself, so on the right-hand side here, you can see that this test for that theoretical API Lambda function, I'm importing the table resource, and I'm importing the Lambda handler, and then I have a PyTest fixture to stub out that table. And then for each one of my tests, I'm actually going to actually add to the stubber an expected response to an API call. I can add those in order in the sequence that I'm expecting, or at least just, you know, the calls that I'm expecting to this that should be executed in code, and they should match this. And then I can set up and then you can see here that I have the params, and then if there is a response that I use in code, I can put a mocked response in there, and this will intercept those. It'll never actually make the AWS call. It will validate that my code input what it should have input, and then it will return that mock result if I needed one. In this case, you can see service response, there's nothing there. This is pretty fast. We're going to get into some of that opinionated development piece. I don't see a lot of value in mocking AWS services for local development. I think you're putting in a lot of effort for very little gain, especially when once you actually get it out in AWS, the things that you're going to fail at are the stubber and your mocked service would not have picked up on it in the first place. So again, we were getting into a little bit of opinionated development, but we find that using the stubber, it's built into Modo 3, and it's a great way of mocking out the service calls. And Modo 3 will throw up errors on invalid inputs anyway, so pretty good. You can also see right there, there's that assert no pending responses. That right there says that once we're done with it, if we try to move on and there are still pending responses in there because there was supposed to be an API call and it didn't happen, it'll fail that test. So also super handy for catching, oh wait, it didn't, our code didn't make a call it was supposed to. Now, another big thing you'll see here is that a lot of our tests focus on the handler and not so much the individual functions that might make up that Lambda code itself. And that's a big part of like, this is validating the input and output, right? We're going to send some input to the Lambda handler. And then for each one of our test cases, we expect a certain kind of output once the handler is done processing it. So you might find really that like focusing on iterations of the event source into your Lambda handler will actually net you all the test cases that you really want. You can find edge cases really easily. You can just add edge cases over time when you're doing it this way. And your code coverage should be nearly complete if your Lambda function is concise and it's, serving its purpose well. Like this gets back to another reason why we do, each one of our functions does one thing and just that one thing, whatever it might be. It makes writing the tests really easy because they aren't that big. And for the most part, we're just invoking the Lambda handler with a mock event anyway. This isn't supposed to say isolated stack testing. It's just supposed to say dev stack testing, but they're kind of the same thing. A big thing about all of our SAM templates is that they are designed to be able to be independently deployed. So if I'm a developer on the team and I'm asked to work on something, I should be able to clone it and then use the SAM CLI to deploy my own copy of it just on the spot using my own IAM credentials and just inputting a few template parameters, right? I shouldn't need to stand up an entire pipeline or do any of that stuff in order to actually make it so that I can get it out there and make sure it deploys and make sure that the pieces are working. Really, that comes back to like using the SAM CLI and leveraging a SAM config file so that we can quickly do SAM build, SAM deploy over and over again against just our stack to make sure things are good before we actually do a pull request to the integration branch. One thing that we don't do is commit those SAM config files with the repository. Like you didn't see them on the that repo screenshot that we were walking through earlier. To me, SAM config files are very much tailored on a per developer basis. Like you're not going to record the stack name in there. You're probably not going to record the region in there. Like a lot of our templates are, all of our templates are region agnostic as long as they don't have CloudFront in them. So that's kind of like the big thing there. Like, use the tooling, generate the SAM config file you need. It's going to be there in your local copy of it when you need it, but we don't commit those back to the repo. And then once you have this in place, you actually can end up in a really rapid development pattern where you are running PyTest passes, SAM build, you can have SAM build cache results now. So it'll only rebuild Lambda functions that actually had code changes between your deploys, and then you just pipe it right into deploy and it goes out to your stack. Development against AWS can start iterating really quickly if you're falling into this pattern. Which does raise the question about like, well, Bryson, what about SAM local? We don't use it for testing. And the challenge back I have before anyone goes, aha, is just that what is SAM local actually doing for you? You are hitting it with a mock event source and making sure that it outputs the result you wanted. Well, we actually achieved that through PyTest earlier. When I said that we focus on the Lambda handlers and we pass in mock events, well, we do use SAM local so that we can generate the skeletons of those events to create out our suite of test cases to throw at it. So an API function, we will generate the API gateway event for it, and then we'll customize it for the test cases that we want to cover. And then we will have a whole array of those ready to throw at the handler and run through all those test cases. And we don't have to spin up the local stack of it. We don't have to do the SAM invoke function in order to do that. It'll just run the entire gamut really rapidly every single time that we run PyTest. So that being said, there are a lot of people who use SAM local to run local environments. They will also run, it works really well when you have a simple application that is just an API gateway and some Lambda functions. And if you are really hot on the idea of running SAM local, you're probably running DynamoDB local already anyway. So you have both of those hooked up together. That's cool. All I can say is do what feels good. My only caution is that it's probably going to work great on your machine, and your machine is not AWS. So the amount of time that you think that you're saving with local development may not actually be saved at all by the time you get it out there and it's trying to actually, work with IAM and work with permissions and work with different event sources hooking up to your functions. You can't ever be quite sure until it's actually running out there. Which now moves us finally into the next portion of this, which is getting the code out to GitHub, opening up a pull request. So we've got all this groundwork. We all of our repos look pretty much the same. We surrendered our will to Black. It auto formats our code. We make sure that we're using PyTest for everything. But that's all local developer environment. What happens when it's time to merge it back to the integration branch? And this is where we start talking about GitHub Actions. They got teased earlier. We're going to talk about them now because they're quite frankly amazing. So GitHub Actions are automated workflows that run within GitHub on GitHub triggers. In our case, it's really the pull request trigger, but there's so many to choose from. They are defined as code in your repo. So that automated test file that you saw under the GitHub directory, that is a YAML file that defines an entire workflow, and that will run automatically for the event that is defined inside that. These count as status checks, which means that your workflows can block pull requests if they are failing. That's a good thing. Now, they aren't exactly free. They're kind of free, but they aren't really free. They're free like the AWS free tier, You can go so far and then they want money from you. We happen to be on team account, so we have a little bit more. We got 3,000 minutes of runtime. So however long it takes that workflow to run, that's going to get docked against our runtime. And then the storage piece is less important for us. But if you're taking advantage of things like GitHub's package service, where you can actually publish your software packages to GitHub, that counts against your storage. So it's free up to a limit, which we haven't hit yet as far as I know. And then after that, it's not so bad. It's 0.008 cents, $8. It's not quite a penny per minute if you're running Linux workflows, and then 25 cents per gig. But again, we're not really using the storage portion of it. So this is what the contents of that file look like. As I mentioned before, we listen on the pull request trigger, and we actually look for every single one. You can make this much more fine-grained if you only wanted to trigger on pull requests meeting certain conditions. In our case, even if it's lower branches that are feature branches merging back to feature branches or anything, like we actually want, or even if they're draft pull requests, it's kind of valuable just to have that automated test run every single time so the developer in GitHub can see whether or not the workflow is completing. So this is pretty basic. Our use of GitHub Actions here is pretty basic. If you go look at the docs, there is a ton you can do in here. We keep it fairly focused and pretty tight because one thing you might see here is that I'm not leveraging any secrets in this file. So there is no AWS IAM user credentials that I've had to store with the repo in order to pass along to this to go do something, because I don't consider that to be a really great idea. There are use cases for it, and there are times that you're going to want to do it, but try to keep things in the area that they best belong in. And one of the best things that IAM credentials belong in are short-term credentials off of roles while you're running within your AWS account, instead of generating a user and then delegating the keys down to something in order for it to call back in AWS. We don't need that in this, because GitHub later on is going to let AWS know, hey, a pull request got merged. We'll talk about that, but that event will kick off everything that needs to happen. So there's no real reason for us to store IAM secrets at this stage. First thing it's going to do is it's going to check out the repo at the ref or the SHA that that pull request is on. So it's going to get a copy of that developer's changes. Then we're going to set up our Python environment. All of our serverless apps are Python 3.8. You would tweak this as needed for what you're doing. Then we're going to set up our then we're going to set up all the packages. So one thing that got missed here, you have to install pipenv first. But you can do that in one step, just a multi-line command. So pip install pipenv, and then you run the pipenv install with a couple more flags than this, mind you. I think it's dev, deploy, and one other flag I think that I left off of this. But the idea is that it is creating a replica of the environment as defined by the lock file with no other changes. Then we get into the tests that run every single time. And the first thing that happens is the linter. Is your CloudFormation template even valid? So CFN lint, that is the tool that we like for this. SAM validate, we don't like for this so much. And that goes back to what I was just talking about, because for whatever reason, SAM validate wants IAM credentials to be able to go do its thing because it reaches out to AWS to perform the transform out there, I believe. CFN lint works with SAM templates. And CFN lint also catches more things than SAM validate does. Like SAM validate will validate the transform is going to work, but it's not going to validate a lot of other things about that CloudFormation template. And we're more concerned that the CloudFormation resources across the board are valid. There's even an open GitHub issue at the time of this where somebody is calling out, hey, SAM validate should do this and the validation portion that it covers all in one shot, which I agree with. I also think you should do the transforms locally instead of reaching out to AWS, but I can also understand why they do it. In this case, CFN lint is great. It'll validate the template. It'll fail out right here if the template is invalid, like syntax errors, invalid resources, whatever. And then it will it'll allow us to move on without using any credentials. Then we're going to run the black check. We're going to make sure the code was actually formatted. We are going to reject the pull request at this stage if the developer wrote any code that didn't go through the formatter. Like, it's not ready for review, format your code, resubmit. I gotcha here. Black changes its mind about what's correct with every update. So across all of our projects, we had to agree which pre-release version of Black we were going to standardize on because it's not on version 1 yet. I think what we're currently using is version 20B. I think, but that's one important thing. If you're doing this, our formatter changes its mind about things with every single update, and that's called out, and that's expected behavior. So standardize on which one you're going to do, and if you're going to go to a new one, you got to move the whole thing. Like you can't have developers you can't have developers mismatching the versions of Black that they're using when they're actually working on the repos. Most of our repos now actually have Black as a dependency in the developer in the dev packages portion of the pip file in order to avoid this altogether. So it's actually using the version of Black that was defined with this project. And then finally, we run PyTest. And PyTest will go through every single test that was defined, and it will bomb out if you broke any existing tests. Maybe you were in a rush and you didn't run any of the tests. Uh-oh. Am I still on?
Yep. Yeah.
Okay.
It's fine.
I got kicked off the JAMF wireless. Good thing I was plugged in for this.
Wild that the office internet is more risky than your home internet at this point.
I should probably not talk about this right now. I've got my own problem that is causing this, I'm sure. All right, anyway. Something that we don't do, but would also maybe be a good idea at this point is that as a part of PyTest, you can enforce a minimum percentage code coverage. Like, I'm going to say it's actually kind of easy with serverless applications to reach 100% code coverage because you probably shouldn't have any code that doesn't have a path to execution in your Lambda functions anyway. So in most cases, and so far with every single one of our apps, 100% is a valid number to hit. And say like, nope, you missed testing something because we didn't hit 100% coverage on this. Maybe 90% is a little more reasonable. But the point is like, not every one of our repos has a percentage requirement on it, but it does have the requirement that all the tests have to succeed. And the code cover and the percentage coverage is not a bad idea at a certain level, just to ensure that, you added 1,000 lines of code. Oh, you dipped under the percentage because we're missing like 500 lines of that. So to put this all together, we have a new branch that came off the integration branch. We're going to have a pull. We're going to have a pull request from that branch back to the integration branch. That automated testing runs every single time, and it will block that pull request. So all of our SAS checks have to pass. The code has to have passed black formatting. So we're going to know the code's invalid if black can't format it because it'll fail out on the linter portion. And then it will auto format so it all looks the way it's supposed to look. We know the CloudFormation template it passes the sniff test because CFN lint passed it, and all of our tests passed. So old tests and hopefully new tests. And again, like this is where coverage percentage can come into play in order to make sure that someone's not adding a lot of new code and then bombing it out. You can control this on a per app basis, what that percentage value is as a part of the PyTest configuration file. So like, it's probably one of those things where it's good to tweak it as time goes on. So that way you can ensure better code coverage over time. And I'm sure there's automated tools out there that can help with that. Then afterwards, the working branch gets deleted after that merge, and then the merge will trigger the deployment, which takes us to the portion that everybody has probably been waiting for. We are now here. We are in AWS finally. And we are in AWS because that merge triggered a webhook, which alerted AWS that there has been a commit on a branch that it cares about. All right, we're now at the part where I talk about code pipeline and why code pipeline is really not all that bad. It integrates directly with GitHub, which is big. That webhook event goes directly to the source input of the pipeline, and it matches up. So every time the branch that we've linked that pipeline up to has a merge on it, the pipeline automatically triggers and grabs the latest copy of that branch. It integrates with code build. So right after that source step, it's going to launch a code build project. It's going to pass it that artifact from GitHub, and then it's going to be able to go through that build spec file and build our code the way it needs to be built. It integrates with CloudFormation. So you have a source stage, you have a CloudFormation stage with a native cloud build action defined in it. And then you go into your deployment stage and you have just native CloudFormation create update actions right there. Like it's just all part of code pipeline. It integrates into all these things seamlessly. And then this is something that's kind of specific to us, maybe. I don't see a lot of people really talking about having to handle multi-account and multi-region deployments of stacks all that often, but that we somehow kind of stumbled into that as the norm here on the cloud platform team. That's just what we have to do. So one of the great things about Code Pipeline is that we can parallelize the deployment of this application across all those many regions where it's going to go to. And then this whole pipeline itself is actually in its own CloudFormation template, which we saw earlier. So the pipeline is defined as code. So the pipeline can be ripped apart and then redeployed as many times as we want without really affecting anything. Which makes this, minus the GitHub portion, a 100% AWS native stack. There is no customized tooling anywhere in here from the development of the application all the way through the deployment of it. And no, I never want to use code commit. It's there, but I don't want to use it. GitHub is awesome. So I'm probably going to get a call from somebody. All right, so anyway, we're going to talk about that build spec file real quick. In case you've never actually used code build, like what goes on here is the build spec file is a lot like the GitHub action. Like, in fact, they're kind of analogous to each other. Like you could recreate everything that GitHub actions do, but do it in code build. In fact, you can also hook up a GitHub repo to actually use code build on a trigger to do the same thing. It's just that I have found it's a nicer experience just doing that within GitHub because you don't have to deploy any of the code build infrastructure to support it in AWS. Like there's a sort of a chicken and the egg thing. If I want a new repo to start using a GitHub action workflow, all I have to do is include the file and it starts doing it. With code build, there's more steps involved. For this purpose, however, we're using code build to actually build the package the application, and then get those artifacts into S3, which that's just SAM commands. So this also gets into something that I'm going to comment on later about, like, a SAM application, you kind of do them all the same way. We have a build step. So we're going to build those Lambda functions, and we're going to get those Lambda artifacts. And then again, JAMF is kind of interesting, where we've stumbled into this everything's multi-region pattern. So our code build jobs will take an environment variable, which is an array of regions that we're targeting. And then for each one of those regions, it'll go through and it'll do the SAM package step in order to actually get those artifacts into the appropriate bucket for that region, and then output a package template for that region. And then all of those package templates will then get, then all those package templates will go into one artifact, which then gets used across all those CloudFormation actions, depending upon the pipeline, because it's really just matching up the name. Like package-US East 2 is only going to get used by the US East 2 CloudFormation action. So now we're going to get into some of the nuts and bolts about, like, well, sure, we have a sanity check at the PR level where it's like, we know all the code is good. We know the template should be good, but like once it starts rolling out, how do we know it's actually good? There is this fantastic thing inside SAM. Well, it's not inside SAM. It's a part of Lambda at this point, where you can enable traffic shifting through code deploy. What SAM does is it completely abstracts away all that code deploy stuff down to a few lines of YAML. So when you add this in, what this will do is it will tell CloudFormation after the transform, you're going to create all these code deploy assets, and then you're going to start a traffic shifting strategy between the old version of this Lambda function and the new version of this Lambda function from the event source. So our API method, the API gateway, we're not trying to mess around with the concept of stages in the API for trying to shift traffic at that level. We're doing it down at the code level. And this traffic shifting pattern here is linear 10% every 1 minute, which means my deployment is going to last 10 minutes. And for every minute of that 10 minutes, 10% more traffic will go to the new code. And then there's an alarm hooked up to this, which set, and that alarm, you can do all sorts of things. Like you could have the alarm listen to both the old function and the new function metrics and see, like, and then you use the error rates from both of them, or maybe it just uses the error rates from the new function, whatever. But the point is, if this alarm breaches, it will kill the CloudFormation deployment and start an automatic stack rollback. That's huge. That is really important. That is a step closer to the future where we all are testing in production, because we have safety nets in place to make it so that, oh, our code is actually causing errors. We're going, like, we have really strict thresholds on that. We're going to roll back now. Oh, hey, look, I had a slide actually to talk about that CloudWatch alarm part. Now, that doesn't always work all the time. Like, you don't always want, like, earlier I'm talking about running SAM build and SAM deploy from the command line, and having my stack update over and over again. Well, I don't want to wait 10 minutes for my dev stack to finish building every single time. So this is where we get into the idea that, like, you add a toggle onto your template as a input parameter that states that if safe deployments are enabled, you're going to use the linear or canary traffic shifting pattern. If they are not enabled, you're going to use all at once. And all at once is another one of the traffic shifting things. It's just that all at once means, oh no, cut over to the new function immediately, and there is no wait. So it's effectively the normal behavior that we see. So yep, allows that. Really good for dev stacks. So that way, developers aren't waiting for their personal stack to deploy over the course of 10 minutes. But then the other thing this opens up is some interesting new patterns that you can explore, which is like the idea of a canary region. So you have to look at applications in this way. And the GitHub flow talks about this, where the GitHub flow is really best around applications that continuously deploy, which means you're always rolling up, you're always rolling forward. You're making a change, you're committing that change goes out in the world. So you have to approach development from the standpoint of, no matter what, your code changes, additions, extensions, whatever, have to not break old functionality anyway, because you have to have a migration path. So you can introduce new things, you just have to make sure you don't break the old things, and then you have to fully migrate everything off before you retire that old code anyway. So what you can do here You could just do that, deploy to all the regions. Like, again, I'm talking about from like the JAMF point of view. Like if you're just doing a single region stack, well, just turn this on and use it. But like if you're doing multiple regions, you got a couple of options. One is maybe there's an environmental thing and a couple of regions succeed and then one region fails. Well, that one region shouldn't be that big of a deal. It just means it doesn't have access to the new functionality. You have to go address the problem and then update it. It might be as simple of a thing as like you take it out of Route 53 until you can address the issue in that region, whatever. The other thing you could do is you could designate like one of your busiest regions as your canary region, or maybe one of your least busiest regions as your canary region. That region goes first, and that region has safe deployments turned on, and maybe its deployment is a much wider window than just 10 minutes. And then as long as this traffic shifting pattern doesn't trip any alarms and it succeeds, then all the remaining regions don't do a traffic shifting pattern, they just get the new code. See, I lost it again. There we go. So that's good if you have an application that actually has a whole lot of traffic that's fairly constant, and you're always guaranteed to have someone using the things that you're changing. But that's not always going to be the case. So then we get into the realm of like, well, I need to be generating some synthetic traffic to my system. Like I need to be generating pathways to my code in the environment alongside users probably to make sure that like I'm actually hitting everything, and then I might want to be sustaining it throughout the window of the deployment. There we go. All right. So one of the ways that we do this right now is we're actually leveraging code pipeline events. So for one of our stacks, we actually are listening to the events that specific code pipelines emit into EventBridge, and then we will go trigger our system suite of tests based on that. One of our applications actually does sort of a Git flow progression where we have a develop branch, a stage branch, and a main branch, and each one of those maps to an environment. And what this pattern does for us is we don't use the Lambda safe deployments in that because we started it before it was really a thing. So what it actually does is it listens for the pipeline to complete, and then it will issue it'll issue out an event, which will then go trigger a system test suite, which actually is a step function, which parallelizes all the different test cases against our API that we want to run. And then if that doesn't pass, then we can roll back that branch if we need to. Like we won't roll back the develop branch because again, we have to like roll forward, but we could revert the staging environment branch back to the last known good state, fix things in the develop branch, and then let it roll forward again. But then like that staging environment branch, never gets merged up to main because there was a failure at the staging level. And really, if the system tests pass and develop, because these are automated GitHub pull requests that we're doing in the background. If the system tests don't pass and develop, or they did pass and develop, but they didn't pass in staging, that could be an external factor that's actually blocking us. So that's what we've been working on for this much larger service that does interesting things, which hopefully in the near future, I'll get to talk more about it. The other thing that we can do, and this is where I get into stuff that I've been working on and trying to pilot out and then really take advantage of, is we can take advantage of pre-traffic hooks. So we're going to go back to those safe deployment options that we were just talking about to talk about this pattern here. A pre-traffic hook is really it's another Lambda function that gets invoked before traffic shifting begins. So that means the new version of the code is out there. Both versions are deployed effectively, but it's not been hooked up yet, and code deploy hasn't been shifting traffic over according to whatever pattern you've determined. So, yep, there we go. So what happens here is this Lambda function that's your pre-traffic hook is going to get invoked asynchronously, which means it's going to get an event fired off to it, but the thing's not going to wait for it to respond. That event is going to contain a deployment ID for a code deploy. And then it's also going to contain a token of some sort. You'll have to forgive me. I don't quite remember the name of it. But whatever is running has to reply back to code deploy with a status update. in order to let it know what the result of it is. And it'll use those two values that were hit with, that the pre-traffic Lambda was hit with, in order to do that. And the beautiful thing about this is that CloudFormation will not complete the deployment until that pre-hook event has been satisfied, which means that you can use that pre-hook to emit a message somewhere to kick off a runner, which will start generating live traffic to your service while your deployment is happening. So you can just hit it with synthetic tests alongside your customers, pretty much have a mock customer or a mock client running out there, hitting all your endpoints and then generating traffic. So that way, as traffic shifting continues, you start, more and more hitting the new code, and you can be sure that your service is actually being used, and then that code deploy traffic shifting is actually getting you some value. Because again, like if you have an application that has constant traffic to it, not so much of an issue. If you have an application where it's spiky, or like certain areas of it get used more than others at different times, you might do a deployment where you get 0 events flowing through, and then your traffic shifting pattern did nothing for you because there was nothing to execute. You can leverage this to hit specific, because you can use the same Lambda function across all your application functions for this pre-traffic hook. And you can really just be an event router. It's like, okay, all of these parts of this application hit me saying like, hey, I'm doing a pre-traffic invoke for me because I'm updating. So then I can then fan that out to whatever is running all my automated tests on the side, step functions like we do or whatever. And then they can start hitting the service over the X number of minutes that traffic shifting is going to be happening. So at the high level, this is kind of what it looks like. On the far left, our developer is working on their EMAC. They work on their short-lived branch. They got their feature done. They open it up a PR to GitHub. That's going to trigger our automated testing of the workflows. That all has to pass. It has to get its whatever minimum number of reviewers from the team approved, merged, triggers a GitHub webhook, goes into code pipeline. Code pipeline triggers the code build project. It builds all of our code for each region that we want, puts it into the artifact buckets as appropriate, hits the canary region. The canary region will use the pre-traffic hook to generate the synthetic clients that will hammer away at it throughout the course of the deployment. That canary region succeeds, all the other regions go in one shot. That canary region fails, it rolls back to last known good state, and you go back to the beginning to fix whatever happened. So now I'm going to talk a little bit about future stuff. And these are things that I have been working on, but also been kicking around a little bit because there were some holes, and AWS recently filled those holes. So there's a lot still to be desired with this CI/CD experience, because some of you are probably looking at it saying like, well, what about this? One of the first things that I'm very much aware of is the fact that nearly every single one of our pipelines are identical. The build spec file is effectively identical. Like, we might change some labels here and there, but they're effectively identical. You're running SAM build, and then you're running SAM package. The source step is the same. The code build step is the same. The only difference in the CloudFormation steps effectively is how many regions are we doing? Like, developers shouldn't have to include a pipeline template with the repository every single time and then have to manage it. And there's an asterisk here because we also do a little bit of dark voodoo magic here with some of our projects. You can have code pipeline update itself off of the template that's in the repo that triggered that code pipeline. It does work. I just melted AJ's mind a little bit. And
yeah, I was with you up until you said from the same repo. I was not.
I'm sure there'll be questions about that. It does work. It is kind of cool, but it's, again, you have a pipeline for every single application slash repo slash environment, which gets into the whole thing about, this is what people don't like about code pipeline. And this was why I was kind of like wording it the way I did before. Code pipeline is a one-to-one solution. You have one repo to one pipeline, but it's also to one environment. Like, if you want to have separately pipelined dev and stage environments, or stage and prod environments, whatever. Those are separate pipelines usually, unless you build one mega pipeline that has full access into 2 different accounts, or you're running it all in the same account, which you probably shouldn't be doing. Just throw that out there. But the other problem with code pipeline is that it's not dynamic. Like, it's also one repo, one branch, one pipeline. It's not going to handle events from branches that you did not hard code into it in the first place. Or, in our case, a parameter, but it's effectively the same thing in the end. That makes it really inflexible. And then when you have to go and modify it, you're copying and pasting a lot of things in that template anyway, because you're expanding it out or you're contracting it. And then, like, if you actually have regional differences between 2 environments, well, then you have to plug a whole bunch of if statements in all over the place. The CDK people are probably laughing right now, but, like, CloudFormation, this is raw CloudFormation. So, like, there are limits to what we can do without getting into custom components. The big thing that AWS filled in this journey I've been on to try and make this better, more dynamic experience is the fact that stack sets now support transforms. So up until 2 weeks ago, you could not use a SAM template in a stack set. So stack sets are a super powerful tool. Stack sets allow you to take one template and then deploy that template across as many accounts and regions in those accounts as your heart desires. And as it so happens here at JAMF, we do have services that we deploy across numerous accounts and numerous regions within those accounts, but it varies. So now that CloudFormation stack sets support the transforms, which means they support SAM, we're almost there. There is a gotcha though, and I called this out on Twitter when it was announced, and that is when you run SAM package, you are hard coding S3 URIs into that package template. And when you do that, you can no longer use it in a stack set because CloudFormation demands that the artifacts that it's interacting with are in the same region, which I don't agree with, but that is how it works. Unless, of course, you were to auto parse package templates after the fact and swap out all the code URIs. And then we get into, like, leveraging GitHub's actions. Because like I said before, GitHub has a whole bunch of events that you can act on. Like, they take advantage of them in GitHub actions. The webhooks themselves can act off a lot of things. Like, you don't have to just be notified on pull requests. You can be notified on any push, really. You can be notified on when new branches are created. You can be notified on when branches are torn down. Like, there's a lot of actionable stuff in there which could make a dynamic pipeline system very powerful. And really, all this stuff together sounds like a really good use case for a step function. So ultimately, where I'm going to try and land by the end of this year is I want to create a developer experience where all they have to do is point the right webhook at something, and then it will handle it from there. And I want to lower that barrier for developers because, like, using the SAM CLI, you can follow a lot of blogs online about the SAM CLI and, like, oh yeah, use SAM build, SAM package, you can use SAM deploy guide mode with the SAM config file. That's not production though. Like, the moment you talk about using SAM in production, you need to have it pipelined. You need to have a way of continuously deploying the changes that you're doing, and you can't do that with a CLI tool on its own from somebody's computer or Cloud9 environment. Just to throw that out there. So rather than telling developers, well, you have to create a pipeline template and you have to have this build spec file, the better path might be, well, if you're building a SAM app, we expect it to act like a SAM app. And as long as it can do SAM build, SAM package, and SAM deploy without an issue, point your repo here and it will just do it. And with that, we'll get into some Q&A. And hey, I didn't do too bad, actually, time-wise.
No, you're great on time. You did great on the presentation, too. I want to reinforce that. Are there any questions, folks? You can open it up. You should be able to unmute. If you can't for whatever reason, feel free to post in chat and I'll unmute you. But I'd love to hear.
Stop screen sharing. There
Sure.
we go.
Yeah. Any questions to start us off?
Don't mind me. My
I have
Zoom window's over here.
I do have one, I guess, if folks are maybe shy. So you talked towards the end about modifying your code pipeline process as part of the like mutating itself, which is sort of mind blowing, but also sounds like it's kind of a trap. I'm, you know, here I am.
I've had bad things happen to me before.
Although yeah, I was gonna say more of a comment. I'd love to hear a story about like when you discovered you could do that and what you learned from that experience.
I did something that I've not been able to recreate, which was I put the pipeline into an endless loop where it kept trying to update itself. Except I've never been able to recreate it. The basic principle is actually simple. After the source step, you then have a CloudFormation step, and that CloudFormation step is update stack. I don't want to start pulling up code here to try and find it exactly, but pretty much it's going to update the stack that actually deployed that pipeline. And then, and then there's a condition on it. There's a condition that you can set on a pipeline that's separate from that, where you can tell it to automatically restart the pipeline on update. So if you commit code changes to the pipeline template in the repo,
right,
the moment it triggers, it's actually hit that step first. And then if you run a CloudFormation update on a stack and there were no changes, it's kind of like a no-op and it just continues on through. But then if there is an update, that execution stops and the pipeline will automatically restart from the last event that triggered it. And at that point, the pipeline's already been updated and it will just continue through. I'm pretty sure my infinite loop was caused by a problem I had in my CloudFormation template for the pipeline where it was rolling itself back and the event was enough to trigger because it had made a change and it was trying to re-execute itself endlessly because it was rolling back and then trying to update again every single time.
Update itself, yeah.
This was a repo where I didn't have a linter, on the pull request before it actually went through. Nowadays, I wouldn't have that problem. That's probably why we're seeing it again, because we enforce a CloudFormation linter at the pull request step.
Yeah, takes us back to CFN lint. Cool. I think we have a question from Wayne. I'm curious how many teams / people are working on the cloud product. How many people touch a repo? I think Wayne might be getting at the question. You kind of drew a line in the sand here about mono repos versus like a multi or like single app repo, and maybe you'd like to expand on that.
Mono repos are not a bad thing. So what you're trying to do should dictate your architecture as much as the architecture looking really cool on a whiteboard. So in our case, when I talked about like how it was broken up across numerous services, well, some of the things that get involved with that is that one of the things that we're building for, and I don't build the JAMF product, mind you. My team is responsible for the tooling behind the next version of our cloud-hosted platform. So when I'm talking about like the weirdness about what our stack does, it's because a lot of it is managing customer instances and the infrastructure that hosts those customer instances, which means lots of AWS API calls all over the place and dealing with latencies from that. The thing about it, though, is that it's a multi-account architecture. And it was built so that each aspect of the application, like databases, mind you, like we spin up on Aurora clusters. So we actually have a microservice that's fronted by an API that has action endpoints on it for performing actions in that AWS account in that region for managing clusters and managing and then managing actions of the customers that are inside those clusters. So if we have an account that's deployed across 10 regions, we have 10 instances of that API. So, but it's back to just one repo. So if we want to make a change to how the database service works, we make a change to the database service and it doesn't impact the rest of the system because the public APIs to it are their own repo. And then the workflows that trigger off events from those APIs or changes to the database layer are the applications DynamoDB table, those are in their own repos because the idea is that we wanted to break it apart to the point so that we could increment on the API without pushing code to the entire system. And really, again, the fact that we are building something that's meant to work across multiple accounts and numerous regions kind of dictated that. My team is actually not that big. We have 7 engineers on the platform team, I think. I'm not going to count in my head right now, but I think we got about 7 engineers really on our team, and we've built about 20 different small services that make up this really large application. And the thing is, we jump in and out of them all the time. The one thing about a monorepo that you can run into is just that you might have 2 people touching the same part of the code at the same time, and then you have to untangle the merge conflict that arises from that. Our decision to break it up across numerous services kind of mitigates that, because if I'm working on code related to deploying a new instance of JAMF Pro for a customer, that has nothing to do with somebody who's working on the code behind the API that our ops team uses to interface with the environment. So that's just kind of like how that falls. Hopefully that answered your question.
Yeah, it makes sense. Folks, any other questions from the audience here?
Unmute, jump in, hit me with anything.
Yeah, hop in.
I saw a lot of pipenv in there. How have you been liking that? It wasn't too long ago that I had to look at pipenv versus poetry in the Python world.
There are a lot of people who are way too passionate about pipenv versus poetry.
It's a curiosity, not a passion, I would say. It gets the job done regardless, right?
I would just say the thing is, like, I was using pipenv before poetry was started, and it just is stuck with. And as far as like an environment manager, it does the job pretty well. Like, you know, the way that I try to split things out is any packages that are actually used by Lambda functions as a part of the code that gets deployed, those go into just the packages section, or the dependency section, the packages section. And then all the tooling that's just for the dev environment and being able to build and test the code, you know, goes into dev packages in there. You know, so like it gives me some distinction between, you know, what's actually being used in the Lambda functions versus what's just being used to develop the application. And funny thing is, like, Boto 3 always goes in dev packages because we don't follow AWS's advice to package Boto 3. We rely on the version of Boto 3 that's in the environment.
And that hasn't burned you yet?
No. The few times when we will go and do that is when we are trying to take advantage of something that is bleeding new, and it's just not there. And it's like a delay, like several weeks usually before that environment gets updated, which is curious. But
yeah,
like,
I've always been curious as to why AWS included some dependencies. Like, so I understand the AWS SDK, like that's available kind of in any environment, in any language, that's always there. But I was always curious on the Boto 3 for Python, because they don't do the same for Node. They don't have any, you know, Node.js, you get the AWS SDK, and I think that's it. I'm going to get corrected on Twitter here when this recording goes live. But
so as I recall, so Boto 3 is a monolithic SDK. Like, it is big when it unzips. I think with Node.js, you can actually pick and choose which parts you want, and they end up much smaller. I think I saw a GitHub issue recently that said that they are working towards that with Boto 3 as a possibility, which would be really nice. And I might change my tune a little bit about that if I didn't have to grab the entire thing every time. And actually, I need to stand corrected. It's true, most applications I don't package Boto 3. In the largest service that I keep hinting at and not actually naming, we actually do have a fixed version of Boto 3 inside one of our Lambda layers, which Lambda layers
makes
are
sense.
a great use case for that.
Right. I was going to kind of poke on that a little bit if there weren't any other questions. Layers, you know, how much of Lambda layer for what JAMF or you prefer to use is shared dependencies, shared depths, and how much of it is like actual shared business logic, like authentication, right? Like some sort of like decrypting or deflating, HTTP response or things like that, and how much of it is just like core dependencies.
I got 2 use cases for that. So for the big service that we've been working on, we have the AWS common layer that we share across everything, which contains X-Ray, it contains Moto3, and it contains one other thing. So that's one. And then we also have an API common layer, and the API common contains a bunch of shared code that is common across all of our APIs that make up that service. So they will use that. So like one of the things in there is a version handler that will we version our APIs off of headers in this particular use case, and so the version handler actually automatically inspects the event headers and then matches it up to the handler for the correct version for that endpoint that matches up, or it'll reply with a hey, you gave me a bad version that you're trying to invoke. And then like it makes the init portion of the Lambda handler code very clean because it's auto handling things like the response format for API gateway, and then just executing the correct code and passing things along. Like it does stuff like that. We are getting closer and closer to the point where I actually want to write a small DynamoDB client specific for our application, because we do use single table design. And in our case, it's a global table that's a single table design. And it really comes down to like a whole bunch of different key prefixes that mean different things. And we have it all pretty well documented, but there is a lot of code that gets copied and pasted at this point, where a DynamoDB client specifically for our APIs that do interact with that main table would be beneficial.
I'd love to talk to you about that maybe in Twitter DMs or something, because something similar, very, very similar for us. Single table design, multi-service. Yeah, it's a common trend, I think. But yeah, I don't have any other questions. Does anybody else have anything else for Bryson?
Quiet crowd tonight.
Yeah, going once. Okay, well, Bryson, thank you so much for taking the time out of your schedule to present at Serverless MN tonight. Really appreciate it. It's pretty exciting to see you at the office.
It's interesting being here. It's more interesting how empty it is, but it's interesting being back here. I do miss this place. We should start hosting Serverless MN here again once we can actually do that.
Yeah, it simultaneously feels closer than ever and also still pretty far away, but looking forward to seeing everyone here again. But with that, I'll wrap things up. Thank you so much for coming.
Thank you.
Stay tuned. Next month, we don't have someone specifically on the schedule, but I've got a lot of folks that I've been talking to, so I'm really excited. We're gonna have a lot of fun. So last Monday of every month is Serverless MN. We look forward to seeing you at the next one. Thanks again, Bryson. Thanks again, everyone, for attending. Everyone have a great day, night, morning, wherever you are.
Thanks for having me. Good night.
Bye-bye.